This is SpaceTime, Series 29, Episode 53, for broadcast on the 4th of May, 2026. Coming up on SpaceTime, the Milky Way's mysterious black hole gas clouds finally explained, 2 massive solar flares explode out of the Sun, and NASA's Mars rovers show the 2 sides of the red planet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a massive binary star system near Sagittarius A star, a supermassive black hole at the centre of our Milky Way galaxy. The findings, reported in the journal Astronomy and Astrophysics, suggest that the star system may be responsible for a series of mysterious gas clouds which have been observed feeding into Sagittarius A star. The centre of our Milky Way galaxy is a remarkably dense and dynamic region. At its heart, some 27,000 light-years away, lies the supermassive black hole Sagittarius A star, which has some 4.3 million times the mass of our Sun. Most, if not all, galaxies are thought to have supermassive black holes at their centres. These are the monsters which hold the galaxy together and provide the pivot point for their rotation. Sagittarius A star is surrounded by stars, gas and dust moving under extreme gravitational forces. And these surroundings provide a natural laboratory for astronomers who are studying how matter behaves close to a black hole and how these central monsters are supplied with new material. Over the past 20 years, astronomers using infrared observations have discovered several compact gas clouds near Sagittarius A star. These clumps, for want of a better term, are important clues to understanding how gas eventually reaches the black hole. Yet their exact origin and the physical processes that shape them have remained uncertain. In 2012, astronomers identified a first compact ionized gas cloud, which they named G2. It had several times the mass of the Earth and was emitting light from hydrogen and helium, which is fairly typical for hot, dusty gas. G2 follows an elongated orbit around Sagittarius A star, and it shows a faint trailing structure, which astronomers then named G2T. Revisiting earlier observations revealed a similar object, G1, also moving along a similar orbit around the black hole. So, G1, G2 and G2T seem to be denser clumps of gas, all moving within a common stream. Moderate density fluctuations can lead to a clumpy appearance because a cloud's brightness increases with the square of its density. More recently, astronomers found that gas from G2's tail is condensed into a third compact clump moving along a similar path, which the astronomers would have named G3, except that that name had already been taken by a different object. Together, these objects form a coherent structure, the G123 streamer, tracing material that flows through the galactic centre. Calculations show that the infall of one such clump, roughly 1 Earth's mass every decade, would provide enough material to sustain Sagittarius A star's current activity level. So, understanding how these clumps form is therefore key to explaining how the black hole is fueled. Several origins have been proposed: stellar winds from massive nearby stars, explosive events such as supernovae, or tidal stripping of stars by Sagittarius A star itself. To test these ideas, astronomers used adaptive optics-assisted spectrographs which enable sharp infrared spectroscopy. Focusing on the hydrogen bracket gamma emission line, the authors reconstructed the orbits of the 3 gas clouds based on their positions and velocities. Their analysis revealed that G1, G2 and G2T all travel on orbits with almost identical orientation and shape. The chance that 3 unrelated objects share such specific orbital parameters is extremely small, and so this indicates a common origin for all 3 clumps. By tracing the motions of the gas streamer backwards through space and radial velocity, the authors eventually identified a visible source, a massive contact binary star catalogued as IRS 16SW, which is located in a clockwise disk of young stars orbiting Sagittarius A star. The small differences between the G-cloud orbits can be explained by the binary star system's own orbital motion. Follow-up hydrodynamical computer simulations support this conclusion. They show the gas clumps can form where the stellar winds from the binary collide with the surrounding medium, producing a shock front between the two stars. There, gas accumulates and becomes compressed, eventually detaching as individual clumps that travel inwards, exactly like what's observed in the G123 streamer. These findings suggest that stellar winds from massive stars at the galactic centre can continually supply material to feed the black hole. This result connects stellar evolution, gas dynamics and black hole feeding into one consistent picture, showing astronomers how star formation and black hole growth can be linked even in our own galaxy. This is SpaceTime. Still to come, 2 massive solar flares explode out of the Sun, and NASA's Mars rovers show the 2 sides of the red planet. All that and more still to come on SpaceTime. The Sun has just emitted 2 strong solar flares, lasting out into deep space within a day of each other. NASA's Solar Dynamics Observatory captured both explosions, classifying them as X2.4 and X2.5 class events. Solar flares are powerful bursts of energy caused by magnetic field lines from deep inside the Sun bursting through the solar surface, creating dark regions called sunspots, and then twisting, snapping, and finally reconnecting. The twisting happens because different parts of the Sun rotate at different speeds. Studying these intense streams of radiation is important because they can damage or even destroy satellites. They disrupt communications and navigation signals. They can overload power grids on the ground, triggering electrical blackouts. And they expose astronauts and even people in high-flying aircraft to increased radiation exposure. Solar flares are classified on a logarithmic scale according to their strength. The smallest ones are B class, followed by C, then M, and finally X being the largest and most powerful. It's similar to a Richter scale for earthquakes, each letter representing a 10-fold increase in energy output. And so an X-class flare has 10 times the power of an M-class flare and 100 times as strong as a C-class flare. Within each letter classification, there's a finer scale from 1 to 9. B and C-class flares are far too weak to noticeably affect the Earth, so astronomers really only start paying attention when an M-class flare occurs, because these can cause brief radio blackouts at the poles and minor radiation storms that could endanger astronauts. And of course they pay even more attention when it's an X-class flare. Now, unlike the B, C and M-class flares, X-class flares go beyond the 1 to 9 scale. That's because they can reach far higher levels of power. There have been flares more than 10 times the power of an X1. In fact, the most powerful solar flare ever recorded was back in 2003. That was during the last solar maximum, cycle 24. It was so powerful it overloaded the sensors measuring it. They cut out at X17, and the flare was later estimated to be about an X45. The Sun goes through a regular 11-year solar cycle. This starts at solar minimum, where there are often no sunspots on the solar surface, and the Sun is comparatively quiet. This is also where the Sun's poles switch polarity. The magnetic north pole becomes south, and the magnetic south pole becomes north. The last solar minimum was in November 2019. Then gradually over the next 5.5 years, the rate of activity on the Sun increases. It becomes more violent until it reaches solar maximum, which occurred late last year. Then, gradually, the Sun starts to quieten down again, which is what it's doing now. But interestingly, it's during this quietening down period where some of the biggest solar storms can occur. The next solar minimum won't occur until around 2030, and needless to say, we'll keep you informed. This is SpaceTime. Still to come, NASA's Mars rovers show the 2 sides of the red planet, and later in the science report, warnings that a mega El Niño event's expected to develop within the next month or so. All that and more still to come on SpaceTime. NASA's Mars Curiosity and Perseverance rovers have provided astronomers with two very different views of the red planet, which are helping to piece together puzzles on how this near neighbour of Earth has changed and evolved. The two 360-degree landscapes highlight how the missions are revealing details of the red planet's formation, its watery past, and its potential for life. Located 3,775 kilometres apart on almost opposite sides of the red planet, the two car-sized six-wheeled mobile laboratories are both exploring areas that are billions of years old. But as the nearly 15-year-old Curiosity rover reaches ever younger terrain in the foothills of Gale Crater's central peak, 5.5-kilometre-tall Mount Sharp, the 5-year-old Perseverance rover is venturing into some of the oldest landscapes in the entire solar system, the outer ring of Jezero Crater. By time-travelling in opposite directions, the two rovers are filling in missing details about Martian history. Stitched together from 1,031 images taken late last year, Curiosity's latest 360-degree panorama offers a detailed look at a region filled with a vast network of boxwork formations. Resembling giant spiderwebs in orbital images, these strange surface structures have low ridges created by groundwater that once flowed through large cracks and fissures in the bedrock. The minerals left behind harden the rock along the fractures, resulting in erosion-resistant ridges. Meanwhile, Perseverance's panorama focused on a place named Lac de Chaumet, which sits just outside the rim of Jezero Crater. Its 980 images stitched together over the Christmas-New Year holiday period provides a 360-degree view capturing the Jezero rim and the ancient rocks around the crater. Today, both these landscapes are frigid deserts, but evidence of a more dynamic past hides within. When Curiosity landed on the floor of Gale Crater back in 2012, it set out to determine whether Mars once had an environment capable of supporting life as we know it. Within a year, a sample drilled from an ancient lake bed confirmed those conditions were present once, and that included the right chemistry and potential nutrients for microbes to survive and even possibly thrive. Since 2014, Curiosity's been ascending the lower ridges of Mount Sharp, which first began forming when layers of sediment were deposited in a series of lakes. These lakes, ponds and streams dried up, refilled and dried up again over repeated cycles, leaving a record of the mountain's layers that formed in drier eras, a sort of geological history book which scientists can read. And because the lowest layers are the oldest and higher layers are younger, Curiosity is essentially progressing through geological time as it slowly climbs the mountain. Last year, Curiosity's science team documented how they found that the mineral siderite might be storing carbon dioxide that once was part of a thicker early Martian atmosphere. A thicker atmosphere would have retained heat and also allowed water to pool on the surface, thereby suggesting Mars was once a warmer, wetter place, one capable of supporting life. Scientists had long suspected that carbonate minerals such as siderite formed when carbon dioxide dissolved into ancient lakes. But supporting evidence in the guise of these deposits have only rarely been found. The mission also announced the detection of 3 of the largest organic molecules ever discovered on Mars. That was in a sample drilled back in 2013. These long-chain hydrocarbons, possibly the remains of fatty acids, are a milestone in the search for more complex prebiotic chemistry on the red planet. And just this year, scientists announced that a rock Curiosity drilled and analysed back in 2020 includes the most diverse collection of organic molecules ever found on the red planet. Of the 21 carbon-containing molecules identified in the sample, 7 of them were detected here for the first time. Meanwhile, on the other side of the planet, the Perseverance rover, which landed on Mars in 2021, has been studying the origin of ancient rocks within Jezero Crater and the hunt for evidence that microbial life may once have existed there billions of years ago. Molten rock cooled and formed the crater's floor. Then a river fed a lake in the crater, leaving behind sediments where traces of microbes might have been preserved. In 2024, Perseverance discovered a rock named Shayava Falls. It was dotted with what scientists call leopard spots, a pattern formed by chemical reactions that microbes are known to create in rocks here on Earth. It's not proof that life existed on Mars, but it is tantalizing evidence. While Curiosity pulverizes its rock samples for analysis, Perseverance collects samples as intact rock cores, each about the size of a piece of blackboard chalk, and then stores them in metal tubes. Aside from a backup of 10 tubes Perseverance deposited in the sample reserve, the rover keeps all its samples, 23 so far, in an onboard cache. Scientists are hoping that if they ever get enough funds, they'll be able to send a mission to Mars to collect these samples and return them to labs on Earth, where they can investigate them more fully with instruments far bigger and more complicated than those that can be sent to Mars. While the sample return mission funding debate continues, Perseverance continues to investigate other aspects of the red planet. For instance, late last year, mission scientists shared the first recordings of electrical sparks in a passing dust devil, lightning on Mars. That's a phenomenon that had only been theorized before Perseverance's microphone actually caught them. Meanwhile, a separate study detailed how one of Perseverance's cameras was able to capture the first visible light auroras from the surface of another planet. Back to the other side of Mars now, and Curiosity has now left the boxwork region and has started exploring a mountain layer enriched by salty minerals called sulfates. Perseverance, meanwhile, will keep heading towards an area of exceptionally old terrain, including one called the Singing Canyon. Needless to say, we'll keep you informed. This report from NASA TV.
NASA has 2 rovers on Mars, and they're currently exploring completely different chapters of Martian history. They're 2,300 miles apart, or roughly the distance from Los Angeles to Washington, D.C. But the real divide between them isn't miles. It's millions, even billions of years. In and around Jezero Crater, the Perseverance rover is looking back toward Mars's earliest years, searching for signs of ancient microbial life. After exploring an area of the crater that was once an ancient river delta, Perseverance climbed to the crater rim to reach terrain that's nearly 4 billion years old. These rocks were here long before water filled the crater. Scientists even believe some rocks in this area formed when Mars was still shaping its crust and atmosphere, and massive asteroids were pummeling the planet's surface. This terrain is a time capsule from the earliest period of the solar system. Meanwhile, over 2,000 miles to the east, the Curiosity rover is looking for evidence that ancient Mars had the right conditions to support life. Inside Gale Crater, Curiosity is climbing Mount Sharp, a mountain built from layers of sediment deposited over millions of years. Each layer is younger than the one below it, creating a geological timeline that records how Mars changed. So, while Perseverance looks back towards Mars' formative years, asking how the planet came of age, Curiosity is moving forward in time, reading a later story of water, climate, and habitability. Together, they're helping scientists reconstruct how Mars formed, how it changed, and how it went from wet to dry.
This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. The World Meteorological Organization warns that a strong El Niño event's expected to develop within the next month or so. The latest monthly global seasonal climate update signals a clear shift in the equatorial Pacific, with sea surface temperatures rising rapidly, pointing to a likely return of El Niño conditions. In fact, the rise is so dramatic, this event could be the strongest in the past 150 years, surpassing the devastating 1877 El Niño event. El Niño and its opposite, La Niña, are phases of the El Niño Southern Oscillation, or ENSO, one of the most powerful climate patterns on Earth. El Niño is Spanish for little boy, and it was first identified by Peruvian fishers who noticed a sudden drop in their anchovy catch as waters in the eastern Pacific heated up. ENSO events reshape global weather, influencing rainfall, drought, and extreme events right across the planet. El Niño is characterized by a warming of ocean surface temperatures in the central and eastern equatorial Pacific. It typically occurs every 2 to 7 years and lasts around 9 to 12 months. It's usually associated with increased rainfall in parts of Southern America, the southern United States, the Horn of Africa, and Central Asia, and by drought conditions across Australia, Indonesia, and parts of Southern Asia. El Niño's warm water can also fuel hurricanes and cyclones in the central and eastern Pacific Ocean, while it hinders hurricane formation across the Atlantic Ocean. Its opposite, La Niña, which means little girl, causes warmer sea surface temperatures in the western Pacific, an increase in rainfall across eastern Australia, an increased likelihood of hurricane conditions in the Atlantic Basin, and drier conditions across the Americas. New research based on fossil evidence suggests that some of the earliest octopus were enormous, powerful kraken-like predators reaching 20 metres or more in length. The findings, reported in the journal Science, are based on fossilized jaws or beaks hidden inside rock samples from the late Cretaceous spanning between 172 million years ago. Today's octopus are soft-bodied, intelligent, remarkably flexible animals that like to lurk in reefs and hide in crevices or drift through the deep sea. Their lack of bones makes them especially difficult to trace through geological history compared to bony animals or those with shells. So the authors used high-resolution grinding tomography and an artificial intelligence model to study fossils from an extinct finned octopus known as Surata, samples of which have been uncovered from seafloor sediments preserved in Japan and around Vancouver Island in British Columbia. Scientists have uncovered how Australia's iconic 12 apostles were formed. The findings, reported in the Australian Journal of Earth Sciences, shows these geological towers are the result of tectonic plate movements over millions of years, which lifted and then tilted the giant structures out of the sea. The authors say that much like an environmental time capsule, each layer of these giant pillars has preserved information about Earth's climate, tectonic activity, as well as plants and animals over millions of years, including a key time about 13.8 million years ago when the climate was much warmer than what it is today. With only 8 of the 12 apostles remaining, scientists need to study and learn from them while they can. Preliminary research indicates these ancient limestone layers range between 7 and 15 million years old. But the authors discovered microscopic fossils that are more accurately dating the layers to between 8.6 and 14 million years old. While the 12 apostles were pushed out of the sea millions of years ago by shifting tectonic plates, it was only in the last few thousand years, after the last ice age, that coastal erosion exposed and shaped the towering rock pillars that we see in the Great Southern Ocean off the Victorian coast today. A Birmingham man in the United Kingdom claims to have seen a Bigfoot running through the woods while he was taking a stroll with his partner. After searching online and discovering his Bigfoot sighting wasn't the first in that area, the 60-year-old now believes the 7 to 10 foot tall figure may actually have been one of the fabled creatures. Reports and rumours of a Sasquatch-like beast roaming Cannock Chase date back as far as the 1800s. This latest incident took place near Castle Ring Hill Fort. Now, it's worth pointing out that prior to the sighting, Ghostbusters had been playing on the movie channel repeatedly over the previous few days, and the new final series of Stranger Things had just dropped on Netflix. The skeptic's Tim Mendham points out that the supposed sighting happened on a misty day, and importantly, neither the man's partner nor his dog noticed anything.
There's supposedly big feet in virtually every country of the world.
Bigfoots.
Well, Bigfoots, whatever. Unknown animal, humanoid, blah, blah, blah. There's supposed to be, in every country of the world, basically, there's variation of the theme. Australia's obviously got its, Asia, most Asian countries do. Every state of America has their own. And so there's Bigfoots all over the place. So it's not unusual for someone to suggest that they found one in another country. Now, this is in a town near Birmingham in the UK. And you get into the story, you realise that he saw something that was fleeting. A fellow there was walking out with his wife, apparently, going for a walk through the woods, and a broad and upright beast with light and dark flowing fur charging through the Staffordshire beauty spot called Cannock Chase. And it was 7 to 10 foot tall, and naturally, therefore, that means Bigfoot. But it was fleeting. It was like, poof, gone and past him. It was travelling at 15 miles an hour, which is pretty fast for a person to be running. But that's it. That's the evidence they put forward for this Cannock Chase Bigfoot. Now, there are other people who research and they say, yeah, there are supposedly things out there in the bush out that part of the world. It could be anything. I don't know about a 7 to 10 foot tall humanoid with light and dark flowing fur, and so therefore, it's an unknown. I think the evidence for it is pretty weak. One researcher claims to have found a big footprint, saying that this area has history of sightings. Could mean there's something interesting out there or something mundane that people aren't seeing very well. Is it a deer? Is it another person wandering through the forest, and you look at it and you have trouble measuring how tall it is because it might be a distance away, although this one's supposed to be quite close, but it was very fast, so I didn't get a good look.
Basketball player?
Lost in the woods? Who knows? But, there's no other evidence for it apart from a few sightings. sightings, etc. Now, these parts of the world aren't huge forests, right? It's not like the middle of Washington State where you've got enormous ranges of hills and mountains and forests and things. This is a place in Shropshire near Birmingham, which is not exactly known as being a wilderness area. You tend to think if there was something there, it probably would have been found more definitively than these sort of rapid-fire, what was that sort of thing going past. So who knows? There's no evidence to make you think it is true at this stage, apart from some anecdotal suggestions they saw something, and this one researcher who reckons he's found a large footprint bigger than a human footprint. It's interesting. It's another sighting of Bigfoot. You get Bigfoot sightings fairly regularly in the US and different places, and there's still, like the UFOs, there's still no evidence put forward as to what it might be, or even if it does exist at all. Which is a shame, actually, because it'd be pretty fun to have it be true.
I'd love it, yeah.
I wouldn't mind. I've got no objection to Bigfoots being around, right? The same way as I have no objection to Loch Ness Monster and things. The way the UFO movement is going, it's getting to be anti-science, anti-authoritarian. Whereas the Bigfoot and things are not anti-science, it's just pseudoscience, but it's not anti-science, and it's not necessarily anti-authority. It's just saying this is unknown. Not many people talk about a government cover-up of Bigfoot like they do for alien intelligences and bodies and things. So it is a fairly harmless thing. It's fun, it's nice, it gets people out in the woods and go for a walk, which is not a bad thing. But no evidence, still no evidence, no firm evidence, fuzzy photos about as far as they go.
That's the Skeptic's Tim Mindham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.